Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video we're going to be talking about the quadratic formula. I've written the quadratic formula here in blue. It's x equals negative b plus or minus, you need both, that plus and minus, square root of b squared minus 4 times a times c all over 2 times a. Now that looks really complicated, and I promise you it's not. The really great thing about the quadratic formula is that it will work with any factoring problem. So using, I know I've done a lot of videos on traditional factoring, using the AC Xbox method, and those are great strategies, but the only thing is they won't work for every single problem. Quadratic formula will. So it's definitely something you want to have, kind of in your math tool belt moving forward. And so in this video, we're going to look at how it works. One disclosure I do want to make is that in this video, we will have all real solutions. So we won't do any non-real imaginary solutions. I do have a specific video on non-real solutions, so check that out if that's what you're looking for. This video is all going to be just basic quadratic formula. Okay, so one thing that we want to note is that anytime we have a quadratic, remember that means that we have a equation to the power of 2, right? 2 is the highest exponent. It would be graphed in a parabola form, so in a U shape, either U or an upside down U. And we're looking for the x-intercepts. We're looking for, and sometimes you'll hear them called x-intercepts, sometimes they're called roots, sometimes they're called zeros. So that's what we're looking for anytime we're doing any kind of factoring or solving for quadratics. So remember, quadratics are in the form, standard quadratic trinomial is the form y equals, or f of x equals, ax squared plus bx plus c. So a couple things we want to make sure we have before we start with the quadratic formula. First off, you want to make sure it is in this standard form, okay? The ax first, or excuse me, the ax squared first, the just plain x second, and the constant last, okay? The other thing you want to make sure of is that it's set equal to 0. You cannot start solving until it is equal 0. Okay, so looking at this first example here, notice it's in the form ax squared plus bx plus c equals 0. So we're good to go on both of those accounts. Okay, so in order to know what to plug in where, we need to do some labeling. So I want to know what is my a, what is my b, and what is my c. Okay, now remember, a is the coefficient or the number right out front of the x squared. So in this case, you might say, well, there's nothing there. Well, that's an understood 1. Okay, so I don't want 1x squared, I just want the number, okay? Same thing with b. What's in front of the x? Remember, that's the one right there. So in this case, it's a positive 2. And then for my c, that's my constant, I don't just put 8, I want to put negative 8, right? I want the whole thing, the negative 8. Make sure you include the sign with it. Okay, and then we just fill this in. So we have x equals, that's what we're solving for, is our x. X equals negative b. So in this case, we had a positive 2 there, so now it's negative 2. Plus or minus, you need both. The square root of, and then we'll have b squared, b was 2, so we have 2 squared, minus 4, times a is 1, times c is negative 8. Alright, and then all over, and it's important you put the whole thing over 2 times a. Okay, now when we come to simplifying this, the first thing you want to do is simplify what you have underneath the radical. Okay, so not including the radical, just what's underneath the radical. So let's do 2 squared minus 4 times 1 times negative 8. and I get 36. Okay, so at this point I've got x equals -2 plus or minus square root of, when we simplified this, we got 36 all over 2 times a, which is just 2. Okay, so this is our x equals. All right, next thing I want to do is see if we can simplify this radical. So let me just see if that's a perfect square, and hopefully you're thinking 36 is a perfect square, but if you're not sure, just check. The square root of 36 is 6, okay? So we want to go ahead and reduce this square root of 36 to just 6. All right, so we've got x equals -2 plus or minus 6 over 2. Now what we've done here is this is 2 separate equations, okay? 2 separate expressions that we're solving. So we have the -2 plus 6 divided by 2, right? And then we also have -2 minus 6 divided by 2. Okay, we have to account for both. This is 2, this looks like 1, but it's really 2 because of that plus or minus. And then we'd want to solve both of these. Now, -2 plus 6, that's going to give me +4. And +4 divided by 2 is 2. Right? And then -2 minus 6, well, that would be -8. And -8 divided by 2, that would be -4. So notice I have 2 separate answers, and they are both answers. So you may see them written like this, right, just separately. You may have a teacher who wants you to write them like x equals, and then our brace, -4, comma 2, and brace. This would be as a solution set. Either one of these is fine. Okay, so in this case, this parabola would cross the x-axis at -4 and at +2. Let's look at another example. So for this one, we want to, of course want to make sure, is it in standard form, x squared plus bx plus c? Yes. And is it equal to 0? Yes, it is. So we're good to go ahead and label our a, b, and c. So let's see. Our a would be the number out front here. There's nothing there, so that's an understood 1. Our b is -5. And our c is -25. Okay, so let's go ahead and plug them into this blue formula here. X equals -b. Now what's important to note here is b is already negative. Okay, so I have to write -5. Okay, because I've got to account for that b is truly negative, as well as the formula has a negative in it. Okay, plus or minus. Now hopefully you're recognizing that'll reduce to a positive, and that's fine. We'll reduce it when we simplify. Plus or minus square root of b squared. So b is -5 squared. Now something very important here. You might notice that I wrote parentheses around that -5. That is essential. Okay, anytime you're squaring a negative number, you must have parentheses, okay? Otherwise, your answer is not going to be correct, okay? So notice I didn't have parentheses there, and that's because that was a negative. And whether it's, I could have used parentheses, wouldn't have been wrong, but I don't have to. I can be a little more lax there. Here, you must have parentheses or your answer will be wrong, okay? All right, let's keep going. -4 times a, 1, times c, -25. Okay, all over 2 times a. In this case, 1. All right, so let's start by simplifying what's underneath the radical. We won't include the radical sign. So we'll just say -5 squared minus 4 times a times c. All right, and that reduces to 125. All right, so we've got x equals negative times a negative is a positive 5 plus or minus square root of 125 all over 2 times 1 is just 2. Okay, now 125, is that a perfect square? It may be. Let's try it. I think it's always good to try, and it is not, okay? So when you get a long decimal like that, that means it is not. Like this 36 reduced really nicely to just 6, and that was great. Here, it's not as nice. It's a long decimal. Now, you will have some teachers that say it's perfectly fine to use a decimal, okay? And if that's the case, you would just round and then proceed. But once you're at the high school level, particularly at my school, it happens in math 2 or 10th grade math, you have to start simplifying radicals. Okay, now if you have no idea what I'm talking about when I say simplify radicals, you are going to want to stop and go and watch my video on simplifying radicals, because otherwise this next step isn't going to make a whole lot of sense. Okay, so stop, watch that if you need to. But for those of us who won't know about simplifying radicals already, I would want to break down 125, because I know that for sure I can simplify that. So what are 2 things that go into 125 evenly? And I could pick any 2 factors. I'm going to go with 5 and 25, right? 5 is a dead end. I can't break him down anymore, but 25 I could break down to 5 and 5. Remember, this is a square root. It's got a little 2 in there, so that means I'm looking for a set of 2. In this case, there's one set of 2 5s, and this 5 doesn't have a partner. He doesn't have a set of 2, so he has to stay underneath the radical. So at this point, we've got x equals 5, right, plus or minus the 1 5 that got to come out, and the 1 5 times the square root of the 1 5 that had to stay under, all over 2. Now, I would at this point want to ask myself, I've got this weird looking fraction with radicals and plus and minuses, and it looks like a lot. I would want to ask myself, are there fractions here that I can reduce, right? 5 over 2 and 5 over 2. Can I reduce either of those fractions? And I could check. Now, some of you may be thinking, no, 5 over 2 is the lowest form, and you'd be right. How could we double check? Well, just put in your calculator. Let's start with this one. Just 5 divided by 2. This goes back to our radical operations on dividing with radicals. So if you need a reminder of that, please go check out the radical operations video. Okay, but 5 over 2, I get 2.5. Remember, we can hit math, fraction, 1, enter. And then answer is a fraction, yes, enter. So it's math, enter, enter. And you get 5 over 2. So 5 over 2 is a most reduced fraction. That's a good little refresher on making your calculator reduce fractions for you. I always love that trick. All right, so 5 over 2 is as low as it goes. And technically, this is 2 answers written as 1, okay? So I like writing it like this. I prefer to write it like this. However, this could be rewritten as x equals 5 plus 5 square root of 5 over 2 and 5 minus 5 square root of 5 over 2. So notice how we took that plus and that minus and we split them up into 2 answers. Either one of these answers are perfectly acceptable. So you could write it like this or like this, okay? Either one is totally right. Let's look at another example. So 4x squared minus 6x minus 5 equals 0, okay? Luckily, it's already in standard form. It's already set equal to 0. You won't always be that lucky, so just make sure that you do move everything over to the left. And I think in the example that I give you in a minute, you're not going to have an equal 0, okay? So you're going to have to move over to make it equal 0. So I threw a little challenge in there on the you try. But we'll get there in a minute. So for this one, let's go ahead and label my A my B, and my C. All right, my A in this case would be 4. My B is -6. My C is -5. And we're ready to go with the quadratic formula. So x equals -b. So remember, b is already negative. So you may just want to do in your head, okay, that's negative times a negative is a positive. Or if you need to see it, write it out. Negative, that's the one in the formula, times b, -6. Plus or minus square root of, now b, we've got a negative here, so red flag, I gotta be really careful. Put it in parentheses, okay? Minus 4 times a times c. All over this whole thing, over 2 times a. Okay, let's clean this up a little bit by reducing what we have underneath the radical. So -6 squared minus 4 times 4 times -5. And I get 116. Okay. So at this point we've got x equals negative times a negative is a +6 plus or minus square root of 116 all over 2 times 4 is 8. Okay, now 116, is that a perfect square? Well, let's find out. Okay, so let's do the square root of 116. It's always good to check. All right, nope, it is not. I get a long decimal, not a whole number. So that means I'm going to have to simplify this radical if it can be simplified. And 116 definitely can. So I would want to come up with 2 factors that go into 116, any 2 factors. Now, I immediately think of 4 and 29. However, what if you weren't sure? I mean, 116 is a pretty big number to try to just immediately come up with a factor, right? I know 2 would work because it's a even number, but let's review that quick trick of how we could know everything that goes into 116 really quickly. All right, you go to your y equals, and you type in 116 divided by x. Second graph, this pulls up our table. So I see 1 and 116, 2 and 58. There was the one I thought of, 4 and 29. And that looks like it's about it, and that is it. Okay, so we would want to do 4 and 29. Now, 29 is actually, I can't break 29 down anymore. The only factors that go into 29 are 1 and 29. But 4, I can definitely break down into 2 and 2. Remember, it's a square root, so I want pairs of 2s. Sets of 2, I should say. And the 29 stays underneath the radical. He doesn't have a partner. So this is written as x equals, we've got our 6 plus or minus, the 2 is on the outside, okay, the 29 is underneath, and then we have all that over 8. Now, we would want to reduce if possible, okay, so here, the same way here we check to see, could we reduce 5 over 2? Let's see, can we reduce 6 over 8? All right, well, let's check. So we'll use that calculator trick to help remember how we can reduce fractions. Of course, we could do it manually, but 6 divided by 8 gives me the decimal. I hit math, enter, enter. 3 over 4. Okay, so I'm going to go ahead and start reducing this. I'm going to write my new version, my lowest reduced form. So at this point, the 6 is reducing to 3, right? I know I'm going to have that plus or minus. And I know on my bottom is going to be 4. Okay, now let's reduce 2 over 8, because that I could also reduce, right? Remember, the 2 is on the outside of the radical, so I can reduce him. What I cannot do, and this is a common student error, and I wish I pointed this out on this one, but that's okay. We'll point it out here. I cannot do 6 plus 2. Or 6 minus 2. These are not like terms because of that radical. That 2 is tied to the radical through multiplication. I can't just separate them because I want to add. Okay, so that's definitely a common student error I see. They start adding here. We can't do that. Okay, but we can reduce by dividing. So 2 divided by 8, let's see. We get 0.25, which I know is 1/4. So notice the 2 will reduce to 1. The 8 has already been reduced to 4, so it's still 3/4 and 1/4. Okay, and then we have our square root of 29. Okay, so now what's interesting about this is I don't have to have the 1 there. Okay, now that 1, because it's tied to the radical through multiplication, that 1 is actually understood. So I can rewrite this as x equals 3 plus or minus square root of 29 over 4. That's technically the most reduced way to write it. Now, I doubt a teacher would mark you wrong here, or at least I wouldn't mark my students wrong here, but this is what you would see on like a standardized test. They're not going to show that 1 there, okay? So remember, we could write this 2 ways, okay? This would be a perfectly acceptable answer. I could also separate this out into 2, so I could say x equals 3 plus square root of 29 over 4, as well as 3 minus square root of 29 over 4. Okay, so you can go either answer, so this one or this one is perfectly fine. Okay, here's an example for you guys to try. Now, I've thrown you a little bit of a curveball here. Not much, but just a little bit to remind you of your solving rules. I've got x squared plus 6x equals -6. Okay, you are going to want this to be equal to 0 before you use your quadratic formula, okay? So on all the other ones, they were equal to 0. So this one, you've got to move that -6 over, make them positive, so that you'll have an equals 0 before you start. So hint, hint, in case you're struggling, you should have x squared plus 6x plus 6 equals 0. And then you're ready to go ahead and start with the quadratic formula. I will post the answer in the video description below. This has been Miss Smith's Math Tutorials.